Hello my dear boys and girls, welcome to your science class. So last class we have completed our 11th chapter. We learned about the light, shadow and reflection. In today's class we are going to start a new chapter, that is 12th chapter in your textbook, and the name of the chapter is Electricity and Circuits. So electricity and circuits. We have heard much about, we use electricity daily in our life, isn't it? We are in an era of technology and we use electricity throughout, isn't it? We cannot even imagine a life without electricity. We all know the uses of electricity and we know electricity is a useful form of energy. Since childhood onwards we are using this form of energy and we know that this form of energy has a great role in our life. We use electricity to run various home appliances like fan, refrigerator, computer, AC, television, radio, fan, electric bulbs, and we even have electric vehicles now, isn't it? So these are the various forms by which we use electricity. We cannot even imagine a life without electricity, isn't it? So in this class we are going to learn more about electricity, how this electricity form of energy we are using. The simplest form of using electricity is by using electric cell. Electric cell. The simplest form of using electricity is by using electric cell. Electric cell. So dear children, have you heard of the word electric cell or a cell? Yes, you maybe heard the word cell in biology. But here cell means a different thing. Electric cell means a different thing. So now I will show you few electric cell, then you will understand what is this electric cell. So dear children, these are few electric cells which we use in our daily life. We use these electric cells in different equipments. So now let's examine the electric cells. These are also known as batteries and we use this in wristwatches, remotes, toys, cameras, etc. This is an electric cell or a dry cell. Each of these dry cells are having positive and negative terminals. So let's see which is the positive and negative terminal. This type of cells are called pencil cells because it is much thin in size. So dear children, when you examine this cell, here you can see a brass cap. Now near to the brass cap, it's marked plus sign. That means this is the positive terminal of this pencil cell. Now here the down region, you can see a terminal container, a terminal region. Now near this terminal region, it's marked negative. That means this pencil cell has two terminals. This is the positive terminal and this is the negative terminal. So that is how the positive and negative terminals are in a pencil cell. Now let's take an ordinary cell. This ordinary dry cell is much bigger than a pencil cell. So here also you can see a brass cap as well as a terminal region. So near to the brass cap, it's written positive. See, here you can see the positive. That means this is the positive region and here you can see the negative marking. So that means this is the negative region. So this cell, that is an ordinary electrical cell, dry cell, is also having positive and negative terminals. So here in the button cell also you can see a positive mark here. That means this is the positive terminal of the button, whereas this region is the negative terminal. Is the positive terminal and here is the negative terminal. So this button cells also has positive and negative terminal. So dear children, now you know what is an electric cell. A single electric cell is called a battery. single electric cell is called a battery. So you are very familiar with the word battery, and we call all these electric cells as batteries, isn't it? A single cell is what we call a battery. We use these batteries in our daily life. We use such ordinary cells for the working of torch or radios, isn't it? Ordinary cells are used for the working of torch and radio. Yes, they give the electric energy to the equipment, isn't it? Whereas such pencil cells are used inside the remote controls, isn't it? We use in TV remote, we use in AC remote, etc. Now, what is the use of this button-like small cells? What is their use? They also provide energy, isn't it? These button cells are used inside, yes, watches, isn't it? Inside the watches, calculators, then toys, certain toys like torch toys, etc. These button cells are used. So these are the uses of the batteries in our daily life. They provide energy to the equipments. Now, even in cars, motor vehicles, etc., scooters, etc., you may have seen the batteries. They are a bit larger than their batteries we saw now, isn't it? You may have seen the big batteries used inside the cars, scooters, bikes, etc. So whichever be the type of the electric cell or the battery, their function is the same. What is their function? Yes, these batteries, these electric cells provide electric energy to the appliances. Now, we use all these batteries, isn't it? What is the advantage of this type of batteries? What is the advantage of this type of battery? Yes, they are safe to handle, isn't it? Because they are safe to handle. We can touch in both terminals. We don't get any shock and all, isn't it? That means they are safe to handle. So that is the first advantage of the battery. That is, they are safe to handle. They are transportable, isn't it? We can carry these batteries from anywhere to anywhere, isn't it? They are transportable in nature. They are safe to handle. These batteries are also called dry cells, isn't it? Dry cells. They are called dry cells because they are dry in nature. These batteries are dry in nature. That means there is no liquid content and there is no spillage, etc. Hence they are dry in nature. They are safe to handle. So they are safe to handle. They are not easily breakable, isn't it? They are not brittle. They are not easily breakable. So they are easy to handle. Now another advantage is they supply steady current, isn't it? They supply steady current whenever it is needed. So as an example, teacher will show the lighting of a bulb using this batteries. By using this batteries, the red bulb is getting lit, isn't it? And it is steadily glowing. That means a steady current is provided inside this battery. So that is what teacher told. The dry cells provide steady electric current. It is having a steady supply of current. That means the bulb, remote, whichever be the appliance you use, the electricity provided by the battery will be steady. So that is also a use of this battery, dry cells. Now the next thing what we are going to learn is about electric bulb. So teacher have brought a small bulb to your class. So what are the features of the electric bulb? Electric bulb. Yes, electric. What is the use of electric bulb? Yes, electric bulbs are used for light energy, isn't it? This electric bulbs provides its light. Now, how these electric bulbs are providing lights? We will now see the parts of an electric bulb. So, teacher have demonstrated a picture of bulb, a diagram of bulb on board. Now, a bulb has a thin wire that gives light. And that wire that gives light or produce light is what we call filament. It is called filament. Filament. So now whenever you switch on a light, the bulb glows, isn't it? Now we are going to learn how the bulb is getting glowed. That is, when the electricity flows through the filament gets heated, and this hot filament produces light. The filament becomes hot and it glows to produce the light. So that is how the light is produced in a bulb. So this filament is having a fundamental role in glowing of bulb because it is getting heated and thus the bulb is getting glowed. Now we will examine a bulb. So dear children, now we learn about the electric bulb and electric supply, that is batteries, isn't it? So next we will learn about electric circuits. Now what are these electric circuits? The path along which an electric current flows is what we call electric circuit. The path along which the electric flows is what we call an electric circuit. Now, just now we have learned about electric bulbs, and there we told that when the electricity reaches the electric bulb, it glows, isn't it? And we also learned about the dry cells which provides the electricity, isn't it? So teacher will just demonstrate a diagram of electric circuit. A picture is given in your page number 117. So dear children, this is a simple representation of electric circuit, and this diagram is also given in your page number 117. So in this diagram you can see here electric circuit. Here teacher have marked as battery. So what is the function of the battery, dear children? Yes, it has a positive and negative terminal, and its function is to provide the electric current, isn't it? It provides the electric supply. So the current moves from here. Current moves in this direction. It reaches the bulb. Now the bulb glows and the energy is transferred to the negative region. And from the bulb, the current flows through the wire back to the negative region of the battery. So this is how a circuit is formed. Here the energy is flowing from the battery and it reaches the bulb glows and the energy goes back to the battery. And this is how an electric circuit is formed. So this flow of energy, flow of electricity is what we call an electric circuit. Here you can see the current flows from a particular direction. That is, the current flows from the positive direction, positive part of the battery. And the current reaches back at the negative terminal of the battery, isn't it? So this flow of electricity is what we call an electric circuit. So here, through what region does the electricity flows? Yes, here it is indicated the wires, okay? So the electricity flows from the battery to the wires and it reaches the bulb. The bulb glows and later the electricity is passed back to the battery through the wires. So this circuit is what we call a closed circuit. Closed circuit. So dear children, now I want all of you to take your textbook. Now the activity 2. The activity 2 shows few type of connections. It connects the electric bulb and the batteries in different ways. And the experiment is to see whether the bulb glows. So certain arrangements are given from A to F. So teacher will demonstrate the experiment using the DG video. Kindly watch the video carefully.
Activity 3. To light up a bulb with an electric cell. Things needed. 2 plastic-coated copper wires, an electrical cell, a bulb, insulated plastic-coated tape. Method. Take 2 plastic-coated copper wires. With the help of an adult, remove the ends of each copper wire so as to expose the bare wire. Fix one end of an exposed copper wire with a plastic tape to the metal case at the side of the bulb. See position A in the figure. Another exposed copper wire is fixed to the metal tip at the center of the base of the bulb, as shown position B in the figure, with the help of another plastic tape. Now, connect the other end of the first wire to the positive terminal of the electric cell by putting an insulating plastic tape as shown at position C in the figure. Similarly, we connect the other end of the second wire to the negative terminal of the electric cell by putting an insulating plastic tape as shown at position D in the figure. Observation. What do we observe? The bulb will glow. We find problem to hold the copper wires at a fixed place with insulating tape. We can use a bulb holder and can fix the bulb and the wires as shown in the figure. Electric circuit. The bulb glows only when there is flow of electricity. The flow of electricity is known as electric current. When we connect one terminal of the cell to another terminal of the cell through a bulb, we create a closed path and the bulb glows. The path along which an electric current can flow is called an electric circuit or simply circuit. If the circuit, as shown in figure, gets complete, electric current flows through the circuit. This circuit is called a closed circuit. If the circuit as shown in arrangement B, C, E and F is incomplete, electric current does not flow through the circuit and as a result, the bulb does not glow. Such a circuit is called an open circuit.
So dear children, by these experiments you understood when there is a complete path from one terminal to next terminal, that is positive terminal to the negative terminal, only the bulbs glows, isn't it? So certain arrangements when both the circuits are at positive terminal and both the circuits are at the negative terminal, and also if the wire is broken, the bulb does not glow, isn't it? So for the bulb to glow, the circuit should be closed in nature, and also the electric supply should be from the positive terminal to the negative terminal. Now dear children, the next concept what we are going to learn is about electric switch. Electric switch. Electric switch. Electric switch. So dear children, you are very familiar with the word switches, isn't it? What are these switches, dear children? So here also you can see few switches. What are the switches? An electric switch is a simple device used in order to close and open a circuit. An electric switch is a simple device used in order to close and open the circuit. So we just now learned the electricity, the bulb glows only if it has a closed circuit, isn't it? The electricity should have a complete closed path in order to glow the bulb, isn't it? So the function of the switches is to regulate the electric flow. So now here you can see the switch is on. What happens if I switch off? Yes, if I switch off, the electricity goes, isn't it? That means the circuit is getting broken. That means the key is getting opened. Whereas if I switch on the light, it means the key is getting closed. So this is what a switch is. It regulates the flow of electricity in a circuit. So dear children, in your textbook figure 12.8 shows a closed key and an open key. We will examine that now. So dear children, this is a simple representation of an electric switch. Here you can see a circuit. This is representation of a cell, electric cell. Electric energy passes from the positive terminal. So you can see the electric current is passing from the positive, and here this is a representation of bulb. And here the bulb glows and the electricity passes back to the negative terminal. So here you can see a switch. So here we are placing a switch. See, in both these diagrams we are placing a key here. So the function, what happens if the key is closed? If the key is closed, the circuit become closed and the bulb will close. Whereas if the key is open, the circuit also get broken here, isn't it? Broken here, isn't it? That means the electricity will not be flow from this region to the bulb. Hence, the bulb is not glowing in this condition. So this is what the function of the switch is. If the switch is closed, the circuit will be formed. That means the electricity will be passed through this. Whereas if the switch is open, the electricity does not pass. The circuit is not formed in this condition. That is why the bulb is getting glowed here, whereas it is not glowed here. Now, dear children, the activity 3 in your textbook is to make an open switch and a closed switch. So here we are using the safety pins in order to the completion of the circuits. Here the circuit is closed because here the circuit is closed, whereas here the circuit is open. You can see the pin is open here. So dear children, by this experiment we understand how a switch regulates the electric circuit. That is the electric flow through a circuit, isn't it? So by this we are concluding today's class. Before concluding, let's summarize what we have learned in today's class using the DG video. So dear children, today we learned about the electricity, the electric cells or the batteries. We learned about electric bulb. What are the parts of electric bulb? Now, electric circuit we have learned. Also, we have learned about the electric switches. Before concluding, I have to remind you, don't forget to go through the textbook. Before next class, kindly go through the textbook and enhance your learning. See you in next class. Thank you.